Good evening, madam. Myself, I am Paul Reddy, studying in SRIT Engineering College in CSM branch. Today, my topic is examine of a given function at a minimum values of sin x plus sin y plus sin of x plus y. Let us see the stationary steps. Step 1, find differentiation df by dou f by dou x is equal to 0 and dou f by dou y is equal to 0. It means the given function is need to be derived and we need to equals to 0. Now step 2, uh, differentiate with respect to second order derivative is should be we can conclude at L, and second order derivative of m, okay, with respect to y is equal to m, and second order derivative with respect to x and y is equal to n. We can conclude like that. Now step 3, ln, we have one formula in maxima and minima. Ln minus m square is greater than 0 at L is greater than 0, and at that point a comma b are maximum and f of a comma b is maximum values. If ln minus m square is less than and L is greater than, at a comma b is a point of maximum of a comma b is minimum. If ln minus m square is greater than 0 at a comma b, then f of a comma b is not an extreme values for maxima or minima. Neither maxima nor it not be minima. Now we will discuss about the problem. What is the minimum and maximum values of sin x plus sin y plus sin of x plus y? First we need to find out the first order derivative of the sin x plus sin y plus sin of x plus y. It is we can conclude that sin x is converted as cos x, and sin of while doing with respect to x, the y should be constant. So sin y is taken as constant. So 0 value, cos x is converted as cos y, and sin of x plus y we can convert it as cos of x plus y, and we can derivative with respect to y here, cos y plus cos of x plus y. Now double integration of x with respect to x of first integration, it is given as minus sin x minus sin of x plus y, and double integration of y with respect to y is minus sin y minus of sin of x plus y, and double integration with respect to x and y we can it is concluded as sin of x plus y. Now at the extreme value of the function of two variables, f of x is equal to 0 and f of y equal to 0, it means we can conclude that first order derivatives of both with respect to x and y, we can conclude it as a is equal to 0. So cos x plus cos of x plus y is equal to 0, and cos y plus cos of x plus y is equal to 0. Now cos x plus cos of x plus y is equal to cos y plus cos of x plus y. Now cos x is equal to cos y, so x is equal to y. The terms of x and y are equal. Cos x plus cos of x plus x is equal to 0, and cos x plus 2 cos x minus 1 is equal to 0. We are placing that x value in y term or minus 1. Cos x is equal to 12 and x is equal to 3 pi or 5 pi by 3. Now cos x, in while substituting minus 1 value and x is equal to pi, fx of x comma y in that value is equal to 0, and fy of x comma y at pi by 3 comma pi by 3 and 5 pi by 3 comma 5 pi by 3 and n comma n. The points, stationary points are pi by 3 comma pi by 3 and 5 pi by 3 comma 5 by 3, and n comma n are the stationary points of a sin x plus sin y plus sin of x plus y of the given function. Now f of ab is an extreme value of x comma y at f of a comma b is equal to 0, f of y a comma b, and f of double integration of f with respect to x a comma b, and double integration of y with respect to y a comma b minus double integration of x comma y of a comma b is greater than 2. It's the value of that function is greater than 0. So, and this extreme value has a minimum, maximum and minimum according as a f double integration of a comma b, or double integration of y with respect to y also a comma b. Is negative or positive, further investigation is necessary if it is 0. since x is equal to y, f double integration is equal to f double. If we can take as cos x is equal to -1 and x in the place of pi, f of x comma y is equal to 0, f of y with respect to y integration x comma y at pi by 3 comma pi by 3 and 5 pi by 3 comma pi by 3, and n are the points, stationary points. Now the negativity or positive further investigation is necessary if it's 0. Since x is equal to y, f double integration y and minus sin x minus sin 2y, and f of x with respect to y is equal to minus sin 2x, and f double integration with respect to x a comma b, f of double integration a comma b minus f xy of a comma b into 2 minus sin a minus sin 2a equal to sin 2a into 5 pi by 3 plus 2 sin 5 pi by 3 into sin 10 pi by 3, that equal to here sin 2a plus 2 sin a into sin 2a. F double integration of pi by 3 pi comma 3 pi into f double integration of y 3 pi comma 3 pi minus f of x integration with respect to y 3 pi comma 3 pi into 2, that equal to sin 2 into pi 3 pi plus 2 sin of 3 pi into sin 2 pi 3. The point pi by 3 comma pi by 3 with represent an extreme values of the function f of x comma y pi by 3 comma pi by 3 sin of pi by 3 minus 2 pi by 3 is equal to 3 root 3 by 2 comma minus root 3 by 2. So minus root 3 by 2 is less than 0. So the points pi by 3 comma pi by 3 represent the local maximum and values of the function at the maximum is sin of 3 pi plus sin of 3 pi plus sin 2 pi by 3 is equal to root 3 by 2 plus root 3 by 2 plus root 3 by 2. So 3 root 3 by 2 is the maximum value of the given function. Now the points 5 pi by 3 5 pi by 3 is represent an extreme values of the function f double integration with respect to x 5 pi by 3 minus sin 5 pi by 3 minus sin 10 pi by 3 is equal to 3 root 2 plus 3 root 2, that equal to minus 3 root 2 minus root 3 is greater than 0. So the points of 5 pi by 3 represent the local minimum, and values of the function at minimum is sin of 5 pi by 3 plus sin of 5 pi by 3 plus sin of 10 pi by 3, that equal to root 3 minus 2 root 3 by 2 minus root 3 by 2 minus root 3 by 2, so minus of 3 root 3 by 2. The point 5 pi by 3 represent the local minima at the values of the given function. So f of double integration with respect to n function, we have double integration of x and double integration of y with respect to the stationary points of n comma n minus f of x integration with respect to y in stationary points n comma n into 2 is equal to sin 2 pi plus 2 sin pi into sin 2 pi, that equal to 0. F of x comma x pi comma pi f of y pi comma pi, that equal to 2 is equal to 2 sin 2 pi plus 2 sin of pi into sin 2 pi, that equal to 0. The second derivative test fails for the points. However, we see that the values of the function this point sin pi plus sin 2 pi is equal to 0. Here the maximum points, global maximum and minimum points of sin x plus sin y plus sin of x plus y are 3 root 3 by 2 and minus 3 root 3 by 2 respectively. Conclusion: finally I conclude that the minimum and maximum values of the given function sin x plus sin y plus sin of x plus y, hence ln minus m square is greater than 0 and L is less than 0. F of n pi by 3 comma pi by 3, that equal to 3 root 3 by 2. Hence minimum values of ln minus m square is greater than 0 and L is greater than 0. So f of x comma y is the minimum at pi by 3 comma pi by 3. So the minimum value is minus 3 root 3 by 2. Thank you.